the cube root of negative 27. Now, this one's kind of weird. So with cube roots, we'd say that that's equivalent to negative 3 because, well, if we look at our perfect cubes list, bring that out here. I added a couple of extra. Well, we have 27 on here and it's 3. But, you know, dealing with negatives, that's kind of weird. So I want to go ahead and explain that one here by stating that negative 3 times negative 3 times negative 3, that's going to give me a positive times a negative. So that's the same as negative 3 cubed. That's going to give me negative 27. So just, right here, that's positive 9 times negative 3. So negative 3 cubed is negative 27. That would be correct. Before I flip this over, this is going to be page 9. Okay. So just an FYI, I know that I'd used this word in class, and in case I haven't used it yet, I don't want you to get confused. Indices, not indices, but indices. This is actually simply plural for index. So you're not going to say indexes. That's not what it is. It is indices, okay? So just an FYI, I don't want you to use the wrong terminology. Let's go ahead and talk about, since it had come up on our last one, even and odd roots or indices. I think I'll write it below. I just want to make sure everything fits. All right, so let's talk about even roots first. So an example. Let's say we had the square root of 9. Well, that's equivalent to 3. Perfect. Although, what if I had the square root of negative 9? Well, this is not a real number. As a matter of fact, if I have a negative inside the radical, it's actually going to give me an imaginary number, but we're not going to get too far into that right now. So let's choose, because right now that's an index of 2. How about if I had a fourth root? That's also even. How about the fourth root of 16? That means something times something times something times. Oh, hey, we were actually dealing with that on our example on page 8. Yeah, whenever we had this 16 here. So that's 2 times 2 times 2 times 2. That's 4 of them. So it's equivalent to 2. But the fourth root of negative 16, as much as you'd love to say that the answer is negative 2, again, it is not real. Now, on the other hand, actually, I think it will fit on here. Why not? Let's do odd roots. Oops. Sorry. that's going to get chopped off a little. Okay, so let's say that we have the cube root of 8. Oh, I guess I should have written that down below. Oh, well. So we already discussed that one. That one is 2. Okay, well, what if I had the cube root of -8? Oh, this one, on the other hand, because it's odd, my answer is -2. Why? Well, because -2 times -2 times -2, that's going to give me, that's a positive 4 times -2. That's going to give me -8, my radicand. So that totally works. Let's say the fifth root of 243. Oh dear, that's a big number, isn't it? So that one is actually going to be -3. So let's go ahead and test that out. So I have -3 times -3 times -3. Oh dear, that's 1, 2, 3, 4, 5. Okay, so I'm going to go ahead and use my associative property here. And I have one group, which I know would make +9. You know that was recorded, sorry. And then I have another +9. And then let's bring down that -3. So that would be 81 times -3, which is going to give me my -243. So I'm going to go ahead and draw out our last little graphic, and then I'll end the video. So according to this graphic, this is telling us that if we have an even index, we're going to have a positive real number. If we have an even index that is less than 0, so that means that it's a negative, all right? Or sorry, if we have an even index and our radicand is negative, then that means we're not going to have a real number. But if we have an odd index with a positive radicand, we've got a positive real number as our answer. And if we have an odd index with a negative radicand, that's going to give us a negative real number.